Welcome to Systems of Linear Equations. This is 8.8 in your book. What we want to do today is learn what a system is. We want to look at solution to systems, and we want to graph to find solutions or a solution of systems. Okay, so the first thing we're going to do is just tell you what a system is. It sounds really difficult, but all that really means is that there are two equations, and we're looking at a solution that make both equations true. So looking at something they share in common, a point they share, or multiple points they share, or if they share one. Okay, so like this is an example of a system. You have y equals 2x minus 4. You have y equals negative 3x plus 1. A solution to the system is an ordered pair that makes both of these true. And again, you could have one ordered pair. You could have an infinite number of ordered pairs that make it true, and we'll see that in a minute. So look at this first one. Tell whether 2, 7 is a solution. What it's asking is tell whether this point, this xy value, works in this one and makes this true and makes this one true also. If it makes both true, it's a solution to the system. So what you have to do is just substitute. Okay, x is 2, right? Y is 7. So we're going to do the math. We got 4 minus 7. Does that equal negative 3? Okay, it does. So this is a true statement. Over here, what we want to do is substitute negative 4 times 2 plus 2 times 7. And we want to see if that equals 6. Okay, so negative 4 times 2 is negative 8. That's positive 14. This positive 14 plus negative 8 equals 6? Yes, it does. So this one's true. So because it's true in both of them, it is a solution to the system. Okay, let's look at graphing and what that looks like. I don't have a straight edge. I can't really draw straight lines. I can, it just takes time. So I'm going to show you a different way of doing it. If you don't have a straight edge, you get an accurate answer. So we're going to do both of these. We're going to graph both of these. Now we have a slope of m, slope of 2, and a y-intercept of negative 4. Okay, so your first point, 1, 2, 3, 1, 2, 3, 4 is right here. We have a slope of 2, so I'm going to go up 2 and over 1. Now, what I suggest is putting more than 2 dots. Because if you don't, you put a straight edge down, your line may be a little off by the time it gets up here. So I'm going to use the slope to keep putting dots, placing dots on this plane. So go up 2 and over 1 again, up 2 and over 1 again. And I could just keep going with this down and up. I could go down 2 and left 1. All my dots are lined up. Okay. Now, the next one, m is equal to negative 3 and b is 1. Okay, so b is 1. M is negative 3, the slope, so it's down 3 and over 1. Okay, 1, 2, 3, 1. Sorry, I didn't mean to put that there. Let's get that out. 1, 2, 3, 1. 1, 2, 3, 1. So you have a line going this way and a line going this way, and where do they cross? Well, they cross right here. And let me see if I can do something that mimics a line. I think if we do something like this, and again, it's hard to do with this pad, and we got something like this. Yeah, except you'll have arrows in yours. They're going to cross right here. So your answer is where they cross. So they cross at 1, negative 2. So the way I'd write that is 1, negative 2. That would be the answer to this. So I'm going to show the graph, and then where they cross is my answer. Okay, let's keep going with this. I'm going to back out to clean all this stuff up. Here we have 4x plus 2, so we have an m of 4, b of 2. On this one, we have an m of 1 and a b of 2. Okay, so b of 2, we've got a slope of 4, 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. I've got 3 points. I don't need 3 points for this one. This one's easy. Okay, this one I've got a b of 2 and a slope of 1, up 1 over 1. Okay, down 1, left 1. So I've got this line going this way and this line, and it's hard to see, but you can see where they cross. They cross here at the b. I wonder if I can get a, yeah, I don't see that. Okay, so we're going to go, it's going to kind of look like this going down, again with arrows, and then it's going to look like this one going this way, and they're going to cross right there. So the way you would write that is Let's get a pen. Okay, so it's 0, 2 is where they cross. They cross at b equals 2. Okay, backing up, or going forward, I'm backing up here. Now the next one, we've got to do a little something before we graph it. You can graph with intercepts, but I'm going to solve for y. Okay, so what we're going to do is solve this for y. We're going to move the x over. I get a negative y equals negative x minus 3. Then I'm going to change the signs. I don't want a negative, I want a positive. So it's y equals x plus 3. Okay, the next one, move the x over. You get 4y equals 4x plus 12. Then divide by 4. You get, and I'll do this in a different color so you can see the difference, you get y is equal to x plus 3. Now what do you notice about these two? Well, you should notice they're the same equation. And if they're the same equation, we're still going to graph 1, 2, 3. We have a slope of 1. Okay, b is 3, m is 1. Up 1 over 1, up 1 over 1. Okay, and when I graph that, now just know that the graph of this is producing two of the same lines. Okay, so how many points do they have in common? Well, they have more than one point in common. In fact, they have all these points that are on this line in common, and this line keeps going. Okay, so so your answer for this would be, well, in math, what do we call something that's a lot? Well, I hate to say it, say it like that, but infinite. So actually with this one, there's an infinite number of points on this line, and they share those points. So you have an infinite number of solutions. And that's how you can write it. Infinite number of solutions. It's not a hashtag. It's an old-fashioned number sign. Okay? Infinite number of solutions. Okay? And again, anytime you're solving for y and you notice you've got two of the same equations, you need to graph it. But your answer will always be infinite number of solutions. Okay? Let's look at this next one. We certainly want to solve for y. So we're going to solve for y and move the 3x over. When I do, it becomes positive. We get 3x minus 1. Here we get 3x plus 4. Sorry, that's an x. Let's graph this one. Negative 1, up 3, 1, 2, 3 over 1, over 1, up 1, 2, 3 over 1. Okay, then 1, 2, 3 over 1. So I've got a line like that. Let's graph this other one in a different color. This is 4. 1, 2, 3, 4. We got a point here. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, 1, 2, 3 over 1. What does it look like happening with this line? Well, they're never going to cross. Okay, they're parallel. In fact, we can see they're parallel because they have the same slope, but they have different y-intercepts. If they're parallel and they never cross, that means they're not going to have a solution. So with this one, we would just say no solution. Okay, and again, you can see that when we have the same slope, but different y-intercepts or different b, it's a no solution. I can never get a no solution with different slopes, ever. You have to have the same slope to have a no solution. So if you graph something and it doesn't cross on your graph, but it looks like, but they have different slopes, you've done something wrong, okay, with your graphing, because all these today should cross on your graph. But if they have different slopes, they're going to have a solution. They will always have a solution. Okay, moving on. Let me back up and clear this off a little bit so we can look at the next problem. I didn't mean to back up that far. Okay, here, notice before we do anything, we have the same slope. We have different y-intercepts. I know the answer to this before I graph it. It is no solution. You still want to graph it. You need to graph. So you have a b is positive 1. That means and the slope is negative 2, down 2 and over 1. Okay, I'll do a different color for the other graph. B is 5. 1, 2, 3, 4, 5. And it's down 2 over 1. And you can see this line's kind of going this way. This line's going this way. They will never cross. They have the same slope. Okay, different y-intercepts, so it's no solution. Okay, you still need to graph it. Moving on, let's do this last one. And again, I keep going too far. Okay, let's try this. We're going to move the x over. So I get negative y equals negative 2x plus 3, plus negative 3, or minus 3. Okay. I want to change signs because I don't want a negative y. So multiply everything by negative 1. You get y is equal to 2x plus 3. Okay, this one, move the 4 over. you get 2y equals 4x plus 6. Divide by 2, you get y is equal to 2x plus 3. What do you have? Same slope and same y-intercept. That means when we graph these, are the same line. 1, 2, 3 is my point here for B. Up to and over 1 gives me my second point. Okay, I will draw a line through this, but they're the same line, so how many points do they share in common? Well, you got a line on top of a line, they share all the points in common. So it's an infinite number of solutions. That is a 0. My writing's terrible. That's why I did math. Okay, that takes care of graphing. Now let's look at a word problems and see how we're going to handle that. A company offers 2 plans for high-speed internet service. Well, it makes sense because the system has 2 equations. Here you pay $200 for the modem and $30 per month for service. So for plan A, y equals $200 for the modem. That's a one-time charge. It's not multiplied. It's just added one time. So it's 200 plus. This is multiplied. $30 per month means it's adding each month. Okay, so it's 30 times m. We'll just call it x. I don't like m's. X. Okay, 30 times x. The next plan, the modem is free. You don't have anything added, but it's 40 times m. Okay, 40 times m. After how many months are the plans the same? Okay, so the way we want to handle this, we're not going to, you can graph it, okay, and see where they cross. But another way to handle this without graphing is this. We're going to set these equations equal to each other and find out when they're the same. So I'm going to take 40x and set it equal to 200 plus 30x, okay? And I just want to solve for x and see when they're the same. So I'm going to subtract 30x. I get 10x equals 200. I'm going to divide by 10. I get x equals 20. Okay, so after how many months are the plans the same? After 20 months. At 20 months, you pay the exact same amount for plan A and plan B. So at 21 months, which plan is worse? Well, this one, you're going to pay more. You're paying more per month. So after 21 months, this is the worst plan. But before 20 months, okay, like 19, 18, this one costs more. Okay, so if you're going to keep it a long while, then you certainly want to pay less per month and just pay the $200 at the beginning. Okay, and that takes care of systems of equations.